Okay. So we're on 6.1, and we're going to remember first what a convex polygon is. Does anyone remember what a convex polygon is? What does convex mean?
It's kind of like
It's not weird. It's like a normal shape, right? So convex is like the normal one. I like to think that it's the one that doesn't have a dent. There's no like dent or push in this shape. The big formal definition says it's a polygon in which no side that is extended will intersect interior points. That just means it's not poked in, it's not dented. The diagonal of a polygon is a segment that connects any two non-consecutive vertices. So any two vertices that are not directly next to each other. So what we're going to do is we're building up to find the equation for the sum of the interior angles of the polygon. And in order to do that, we are going to think about breaking these polygons into smaller triangles, okay? So we are looking at a 3-sided shape. We are looking at a 4-sided shape. I'm looking at a 5-sided shape, and we're going to end with looking at a 6-sided shape. So we're going to kind of build our way up to this formula. So in a 3-sided shape, can you draw a diagonal? No diagonals. So I only see one triangle here because I can't make any diagonals to make more triangles. And so it's a 3-sided polygon. There's only one triangle itself. And what's the sum of the interior angles of a triangle? 180. Okay, good. We already know that one. Okay. I'm going to a 4-sided shape, and I'm picking any vertex, and I'm going to draw as many diagonals as I can. How many can I draw here? 1. I only can draw 1. So that makes how many triangles now in this shape? 2. Okay. So I've got a 4-sided polygon, and I can make 2 triangles from that. Does anybody already know what the degrees should be, what the sum of the interior angles is in a 4-sided shape?
360.
360, good. And you know what's funny is 360 is the same thing as 2 times 180. Huh, sensing a pattern yet? Whoa. So we know those two. We know 180, we know 360. We probably don't know most of the other one. So that's why we have this formula, so we don't have to memorize all of them. Let's go to our 5-sided shape. So I'm going to make my vertex. We'll say it's here. How many diagonals can I draw this time?
2.
I can draw, yep, I can draw 1 here, and I can draw 1 over here, which makes how many triangles? 3. Okay. So again, I've got a 5-sided polygon with 3 triangles that are formed. And above, we did 2 times 180 to get 360. So I'm going to do 3 times 180 to get 540.
That's possible.
What do you mean that's possible?
I mean, like, it goes 360 is a circle. You can't do it.
Right, but see how I've got all of like this is like all of these together is more than 360 because of all of the inside little angles that we've got. So yeah, you could have like a huge number for the sum of the interior angles. That's a good question. All right, we're gonna do just one more, and then we're gonna make a general statement of this. So now I'm gonna say, let's say this is my vertex that I'm gonna go from. It doesn't truly matter. I'm gonna draw as many diagonals as I can. And how many triangles am I gonna get here? 4. 1, 2, 3, 4. So again, I've got a 6-sided polygon with 4 triangles, and my sum of my interior is going to be what times 180 this time? 4 times 180. And what is 4 times 180? 720. Okay. Now, I just don't want to do this for every possible option that we have, and then we could come back and check this list. We just want to make a formula. We kind of want to make a little equation that's going to be able to help us depending on whatever side triangle or polygon we have. So if I have an n-sided polygon, how many triangles are we going to form? An n-sided. So if I had 3 sides, I had 1 triangle formed. If I had 4 sides, I had 2 triangles formed. What am I doing each time to get there?
Subtracting.
Subtracting what?
Subtracting 2.
2. So if I had n, if I started with n, it's going to be n minus 2 is how many triangles that I can have formed. And what did we do each time to get there?
Multiply.
5.
by 8.
Good. Okay, Janai, I guess you're gonna sit at my desk because I'm out of seats.
Okay.
Have you started any corrections yet? Not. Okay. Do you need a piece of paper?
Yes.
I've got some in the back by that soccer ball. All right, so I'm gonna write n minus 2 times 180. And that is my equation to find the sum of any interior angle shape that I have. So we're gonna use that momentarily. It's right on a roll, but I will get there.
Okay, I'll go
That's
first.
like part of the, that's the whole part of the.
That does it.
All right, so where I was at is that we just got theorem 6.1, which we'll never call it theorem 6.1. It's just the sum of the measure of the interior angles, and it's going to be n minus 2 times 180. So I'm going to highlight that. I might come back to it later. We're going to use that a fair amount. Okay, before we start doing examples with that, I also want to figure out how do we know what the measure of one angle is, not the sum of them, just one. Okay, do you know what the word regular means in terms of a regular polygon? Not 360.
It's,
It's like, it's a normal shape.
Yeah, it's a normal shape, and what makes it normal is that all of the sides are the same, so it's equilateral, and it's equiangular, which means all of my angles are the same.
I was about to say that word, but I wasn't sure.
If yeah, you're like, it's a weird word. I don't want to say it out of context. Yeah. So all angles are congruent and all sides are congruent. So equilateral and equiangular. Now there's two regular polygons that we use all the time. A regular triangle and a regular quadrilateral. So in these, all my sides are the same and all my angles are the same. Do you remember we call a triangle that has all the same sides and all the same angles? Equilateral and equiangular, yeah. I feel like though when you guys were in elementary school, we always called them equilateral triangles, though, right? Yeah. So we decided they're going to be called equilateral triangles. You could also do it with a quadrilateral.
It's easy to say too.
It is easier to say than equiangular. A quadrilateral where all my sides and all my angles are congruent. What do we call that?
Quadrilateral. Perfect square.
A square. A square.
You're smart. Who said square?
Somebody did say square. Eileen, good job.
You're smart. We're all smart.
But like we use the word square all the time. It's something we teach like little kids. But what that means is it's a really special type of quadrilateral.
I just want to say you were square.
Why do they say that?
Because like you're lame, like you're square. Yeah, y'all don't get it, but it's
Those of us who don't get it are squares. Is that what you're saying?
yeah,
Okay, great. All right, so that being said, if we have a regular shape, then that means all of the angles are the same. So I can take the sum of the interior angles and divide by how many there are. So the sum is n minus 2 times 180, and I'm going to divide it by the number of sides / the number of angles I have. Okay. So these two formulas we're going to use on this front paper, and then we're going to use it more on the back side. So we're going to do a lot of examples with these now and on homework. So we got to remember these formulas. Okay, you ready to do a couple examples? Okay, we're going to do these two examples right here. So the first one says, find the value of x in the diagram. Okay, let's first, not 360. How many sides are in the shape?
540.
There are 5 sides, and so we would want to, we'd want to know what the sum of the interior angles of a 5-sided shape are. And if you didn't know 540 off the top of your head, or we hadn't just done it, I would probably do 5 minus 2 times 180. I'd say, okay, 3 times 180, that's 540. So I'm not adding them up to 360, I'm adding them up to 540 because in a pentagon, I have enough angles to get all the way to 540 and add them all up. Why is what?
5 minus 2. Is that just?
That's the formula we just learned, n minus 2. You just plug 5, the number of sides in for n.
If you don't memorize that.
Yeah.
5 has.
If you didn't know that 5 is 540, then you would use this formula. And so I'm going to add up all of the angles. I've got 56 plus 151 plus 90 plus 120 plus x. Add them up and then subtract them from my 540. Get my calculator out for at least 417.
Oh, fine.
123.
This is fun. This is, I like this.
Good.
Wait till we get to next week.
I feel like this is like real geometry. Like this is like what we thought geometry was going to be.
This is light work. This
Uh-huh.
light work.
It is light. Let's do one more.
It kind of is what you would think of geometry, which kind of makes it easier because we're temporary.
Yeah, we're thinking about like these different shapes and finding angles. Yeah. What'd you say? Yeah. All right. So how do I set this one up?
Ooh, can you do 5 times x equals 540?
Yep. Why'd you use 540?
5 times.
5 sides.
Wait, where do we get the
The 5 comes from how many x's I have. All of those angles are the same. So x and x and x.
108.
What'd you say?
108.
Mm-hmm.
108.
108. Very good. It's not bad. All right. We got a little formula at the very bottom. I want to talk about that super quick, and then we're going to move to the other side. It says at each vertex, the measure of the interior angle plus the measure of the exterior angle is equal to 180. Okay, let's draw that. I'll draw another pentagon. Good. Okay, so I've got a little pentagon, and my interior angles are all of these angles on the inside. An exterior angle is if I were to extend the line that my interior angle is on, and that would be the angle on the outside of that shape. That's in the exterior. So my interior angle is here, we can call him X, and I've got an exterior angle here we can call Y. Do you know what we call X and Y?
linear?
Linear pair.
Linear pair. And linear pairs are supplementary. Very good. So think about X plus Y is 180, and they're just 2 angles on the line, so they're supplementary. Okay. All right, let's flip our paper over because we got to learn about exterior angle theorems first, and then we'll do some examples. Yeah. All right, so the exterior angles, and somebody last class was like, I don't really get the exterior angles. Well, the good thing is I'm going to draw most of them for you. So if you look at the box that I have right here, I have 1 and 2 and 3 and 4 and 5. They're all exterior angles because they're right next to the shape, but it's like if I extended the line out a little bit. The sum of the measure of the exterior angles of a polygon is always, always, always 360. No matter what shape, no matter how many sides, no matter how many angles, the sum of the exterior is always 360. This, yep, if I add up angles 1, 2, 3, 4, and 5, it will equal 360 for any shape.
Any shape?
Any shape. A 12-sided shape, a 4-sided shape, a 22-sided shape. All of them will add up to 360. That being said, to find the measure of each single exterior angle of an n-gon is going to be 360 divided by how many angles I have, which is going to be n. Let me clean that up a little bit. 360 divided by n. This is not a blank, so you can ignore that. Okay. All right, we got two examples that are drawn. So 360 divided by n is how you find one angle. In my other class, I wrote just one angle as opposed to the sum. That might kind of help you figure that one out, just one angle. And so we're going to go solve these. If I look at the first example I have, I've got all of these angle measurements. And what is the sum of the exterior angles? 360. So I'm going to add them up and set them equal to 360. What's this one that doesn't have anything on it, though? What do we call that angle? 90. Very good. I got a little 90-degree angles there. 90. Okay, so I've got 2x plus 90 plus 2x minus 12 plus 32 equals 360.
Wait, what's the one by the right angle? Oh, you just write that.
Uh-huh.
It wasn't minus 12.
Why is it what?
Minus 12.
Because that's what this angle says right there.
Oh,
So I'm going to add my x's up, 2x, x, and 2x is going to be 5x. And then I'm going to add 90 minus 12 plus 32 equals 110. Minus 110 from both sides, divide by 5. 50. All right, any questions yet? All right, let's come over here. Let's solve this one. What's going on here? I need to find x. Is that an interior or an exterior angle? Exterior, good. And what's the sum of all the exterior angles? 360. And how many exterior angles am I going to have here? I have one drawn, but how many total? Why is it 6?
So it's 6-sided.
Good. So the number of sides is the same as the number of interior angles, which is the same as the number of exterior angles. So we see 1, 2, 3, 4, 5, 6 interior angles. We see 6 sides, which means I've got 6 exterior angles. So 360 divided by 6 is 60. So angle X is 60 degrees. You guys are killing it. Anybody questions yet? Okay. We're going to do these 5 examples, but I want to bring your attention to the next side of your paper. So if you're online, just scroll down to the next side. If you're in your packet, flip it over. There are no notes on this. This is essentially your Spark Notes version of what's going on. So this is your summary, your Spark Notes of everything that we've learned. I've got my sum of my interior angles is n minus 2 times 180. I've got my sum of my exterior angles is going to be 360 always. It doesn't matter the number of sides or anything else. If the polygon is regular, then I know that the interior angles each measure as n minus 2 times 180 all divided by n. And then if it's regular, each exterior angle is 360 divided by n. Another way to think about it is you can think of it as n equals 360 divided by the angle measured too. So you can kind of go backwards on that one as well. At each vertex, the interior and the exterior angles are supplementary. And if you're given an interior angle, it's often helpful to use the exterior angle to help you solve. So don't be afraid to use that if you need to. Okay. So this is just a Spark Notes version, no notes on here. but I encourage you to like flip back and forth or use this maybe when you're doing your homework because this has all the formulas you need on there. All right, so we're gonna do these 5 examples. Do you want me to walk with you through them or do you want to try them on your own? Walk, okay. The first one says, find the sum of the measure of the interior angles of the convex polygon. Okay, so we want to find the sum of the interior angles. What formula is that?
N minus 2 times 180.
Very good. N minus 2 times 180. What's my N in letter A? 20. So I'm going to do 20 minus 2 times 180.
I'm sorry, what was that?
Would you A and B go together?
There are 2 separate problems with the same directions.
I flipped the table.
You flipped too far. Yep. I showed you that backside and then I wanted you to come back to where we were. Yep. All right, so 20 minus 2 is going to be 18, and 18 times 180, 3,240. I got 3,240. Letter B is super similar. It's still the same directions, but now it says it's a hexagon. How many sides does a hexagon have?
6.
6. So I'm going to do 6 minus 2 times 180. If we have time at the end of class, we'll review those or we'll review them tomorrow. Or next class, whatever.
Is N? Oh, wait.
N is always your number of sides. 720. Okay. All right, so that was letter number 1. Everybody okay with that? Okay, the next one says find the measure of each interior angle of a dodecagon. How do I find each interior angle? Which formula do I use there?
N minus 2 times 180.
Over n. Good. So we have to do the sum and we have to divide it by how many sides there are.
How many sides?
Dodecagon. Does anyone remember what dodeca, what that prefix is?
12.
12. 12. I don't feel like that's when you can be like, oh, duh. Like I feel like octagon, we're like, oh yeah, octopus. You know what I mean? There's ones that we know. Dodeca is not really one that we know, but it's one that we should be knowing. So that's 12. So I'm going to do 12 minus 2 times 180, and then I'm going to divide by 12. So 12 minus 2 is 10. 10 times 180 is going to be 1,800.
Potential spam.
Potential spam. I don't want that.
Your dinner answer.
Maybe the. Hold on. Thank you so much. I got 1,800 and I got to divide that by 12 and I get 150 degrees. All right, questions yet? Okay. Next one, it says, the measure of each interior angle of a regular n-gon is 140. Find the value of n. In other words, how many sides does this polygon have? You know, I did this a little harder last class. I think we can do this easier this class. Okay. So I don't know what kind of polygon I have, but I know that I've got an interior angle that is 140. Can you find the exterior angle?
Yeah.
What is that going to be? 40. My interior angle and my exterior angle are supplementary. So my exterior angle is 40. If my exterior angle is 40, what's the sum of the exterior angles again?
180.
Not 180, 360. So 360 divided by 40 should tell me how many sides that I have. Most recent quiz? Yeah.
Wait, hold on. Why can't you just subtract divided by the rest. Wait, wait, because you don't know how many sides you have.
I don't know how many sides I have. Mm-hmm.
That's very
Okay, so what formula was that in Ronnie?
What formula was that?
360 divided by n.
360 divided by the angle measure, which is like, which finds n. I'll show you a harder way, but I think once you see the harder way, I think you're like, oh yeah, I'm gonna do this way. So it's gonna be 9. And nonagon. Very good.
It's only 5. 5 problems.
Yeah, you only have 5 pounds.
I think so, we don't.
We're gonna no, she has a quiz. We're gonna get into some of 6.2. A harder way you could have done this is we could have used the formula that we used above. We could have used n minus 2 times 180 divided by n, and we could have set that equal to 140. So 140 equals n minus 2 times 180 divided by n, and we could solve that. This isn't that much harder. The only thing is we're going to get n's on both sides. So I would like to multiply by n so I don't have n by itself in the denominator anymore. So that gives me 140n. And I would also like to distribute on the numerator. So that's not 2 minus or n minus 2 times 180. It's going to be 180n minus 360. You don't have to write this if you like the other way that I did it. It's still going to be 9. And then I would minus my 180 from both sides and divide by, I think that would be negative 40. So, yeah, negative 40 equals negative 360. Oh yeah, the final answer will not be negative. I like that you knew that, and we're like, it can't be that. But now I'm going to divide by negative 40, and that will give me a positive 9. So you could do it one of 2 ways. The easier way, I think, is figuring out using the exterior angle, but you're also welcome to use the interior angle and use the formula we were using last time. So again, both of those methods are correct. The exterior angle might be easier. Questions yet?
Say you had 2 exterior angles, you didn't know how many sides you had. Could you add those 2 angles together and then divide 360 by those added, or you still have to divide it by this one?
I think you would still divide it by just 1 because those 2 angles should be the same in order for us to find out how many sides it is. If those angles are not the same, then we don't have any way to figure it out. Good question. All right, what else? Anybody questions? All right, 2 more examples here, and then we're going to get into some 6.2 notes. This says the measure of each exterior angle of a regular n-gon is 10. The measure of each exterior angle of a regular n-gon is 10. So that's very similar to what we did last time. But this time my shape has 10 on the outside, and I truly don't care about the inside. If each exterior angle is 10 degrees, how do I figure out how many sides I have? 360 divided by 10, just like we did last round. So you can divide by the number of sides, or you can divide by the degree that we have, and you'll get the missing one. So we just did 2 examples where we divided by the degree, and then that tells us how many sides we have. 360 is always the sum of the exterior angles. Yeah, that's okay. 360 is always the sum of the exterior angles. Yeah, Chase. Yes, you may.
It's always going to be divided by 360, or 360 divided by whatever you're given.
Yes, either the angles or the sides. So let's do the last one. It says a regular polygon has 15 sides. Find the measure of each exterior angle. What do I do to find the measure of each exterior angle? Why is it 360 divided by 15?
Because it's the opposite now.
We are doing opposite of what we were just doing. And why was it 360? Why was it not another number? Good. The sum of the exterior angles is 360. So there was no math to find that. We just had to remember that. And then we're going to divide those 2.
But aren't we're finding the sides last time, and then we're finding the angles.
But we're still doing the same thing. I still am taking the total. Because no matter what, the sides times the angle measure, the degree, should always add up, or should always equal 360. So no matter, like, if there's 10 sides and they're all whatever, like, that's how we do that. So this time I'm just dividing by 15 and I should get 24 degrees, right? Okay. All right. Okay, we're doing good on time. Anybody have any questions? Because we're going to jump into 6.2 now. We're going to talk about parallelograms. Have you guys learned parallelograms?
Yeah.
Oh, okay, perfect. Last class acted like I was talking crazy. So I want to do just the basic rules of parallelograms. That's the first page. And then I want to do 2 examples on the next side, so you've got enough practice to do some homework, okay? Your homework is not due until Tuesday, so I know I'm forcing a lot right now, but I want to be able to review some stuff later. So if this is easy stuff that we don't need to, like, waste any time doing, we're going to go through it pretty quickly, okay? All right, so parallelograms. We're going to talk about properties, and there are 5 main things that we need to know, and we're going to learn them from either definitions or theorems. So the first, we're going to skip that box at first. We're going to fill that in as we go through each theorem and definition. Okay, the definition, a parallelogram is blank with 2 pairs of opposite sides that are blank. How many sides does a parallelogram have? 4, so it's a quadrilateral. And its 2 pairs of opposite sides are parallel. Very good. By definition, a parallelogram has 2 pairs of opposite sides that are parallel. So I'm going to draw in my picture, I'm going to draw the little arrows to represent parallel. So on one pair of sides, I'm going to draw just like 1 arrow. And then on another pair of sides, I'm going to draw 2 little arrows. It doesn't matter. Say again? I think it more matters that there are 2 of them or 1 of them versus going the same way. But the little arrows in general mean parallel. All right, so I'm going to write this definition as one of my properties. I'm going to say if a quad is a p-gram, if a quadrilateral is a parallelogram, then there are 2 pairs of opposite sides that are parallel. It is right over here. Can you see that? Okay, perfect. If a quad is a p-gram, then there are 2 pairs of opposite sides that are parallel. So that was just the definition we had learned. We talked about already. We knew that one, okay? Everybody good? That's the first thing we need to know about parallelograms. The second thing we need to know about parallelograms is that their opposite sides are what? Their opposite sides are parallel, but they are also congruent. They are congruent, which is nice. We want them to be. Those are going to have 1 mark. These are going to have 2 marks. That shows me that they are congruent. So I'm going to go up to my property number 2, and I'm going to write, if a quad is a p-gram, then opposite sides are congruent. Opposite sides are congruent. Okay, questions yet? Okay, now we're going to deal about angles. So if a quad is a parallelogram, then its consecutive angles are blank. Consecutive means right next to each other. Supplementary. The reason is if we have parallel lines that are cut by a transversal, like Alea, you said it all the way out, consecutive interior angles are supplementary. That was a theorem we learned a long time ago with our parallel lines, and that is true here to this day. So consecutive angles are sup. And when it says, why is this true? We're going to say if lines are parallel, then consecutive interior angles are sup. interior. Because if I come over here, they are in between the two lines that are parallel, not outside. So they're interior, not exterior. And I'm gonna have to go above and write on line number 3, I'm gonna write if a quad is a parallelogram, then consecutive angles suck. So I'm gonna go above and write in 1 second. The quad is a parallelogram. I'm sorry. Consecutive angles are suck. All right, that's 2 of my 5. Everybody okay with that? The next one I think also makes a lot of sense. This time it's going to talk about opposite angles. What do you think is true about opposite angles? Congruent. Angle M is congruent to angle T, and angle H is congruent to angle A. Those are congruent. So opposite angles are congruent. And I'm going to come here and write opposite angles are congruent. The very last one I don't think is super common sense, so I'm going to say it and not make you kind of guess your way through it. I think the rest of these made sense. Either you knew them or it was pretty easy to determine, A, based on how it looks, and B, based on what we know about parallel lines, but this next one's not necessarily. Yeah, Alea. Not reflexive. This has to do with their diagonals. Not vertical. There are vertical angles there, but I'm not going to write a theorem about it. The diagonals both go through this point A, and they bisect each other. So that means GA and AO are congruent, and MA and AE are congruent. So we can say this one of 2 ways. We can say diagonals bisect each other, or we can say they share a midpoint. Diagonals bisect each other. Yeah, let me have it over here. Thank you so much.
Thank you.
Bye, Cam. Have a good weekend. Thanks. Another way of saying that the diagonals bisect each other is that they share a midpoint. That's okay. It means the same thing. Now, are the diagonals of the parallelogram congruent? Does it look like GO is the same length as ME?
No, yes, no.
No. This one's not a super great way to show it. They're not. I'm trying to think of. See if I can make it more dramatic.
Oh, yeah, because the line is further on that line.
Mm-hmm. So I'm trying to make this one a little bit more dramatic. I think it's a little bit more obvious here that like this diagonal that I just drew is much shorter than this one, right? So by definition, their diagonals could be congruent, but they don't have to be. That's not a theorem that's always true about them.
Is it always congruent square?
And we're gonna get to those properties later. Yeah. So you're going a few too many days ahead of me, Chase. Slow it down. Now, do the diagonals bisect the angles? Do the diagonals bisect this angle M? Are those 2 angles the same? No. And that's another one. Like, I know it's not a great excuse to be like, oh, they don't look it. They don't look it, but it's also not a true statement. So that one is also no. So the diagonals are bisected, but that doesn't mean that the diagonals are congruent, and it doesn't mean that the diagonals bisect the angles. The diagonals bisect each other. So I'm going to come up here, and I'm going to say the diagonals bisect each other. Opposite angles are congruent. You can write either diagonals bisect each other, or you could write share a midpoint, whichever makes you happy. I'll zoom out so you can look at those. See me? Yeah. This everything we just did on the first page is now in that box. Flip it over. We're going to do 2 examples.
Oh my God, it's so.
I emailed them as well, but.
Yeah.
Just texting.
Yeah, it is. Yeah, of course.
Thank you. Sorry to interrupt.
Of course, you're fine. We can in the rain, not in the thunder and lightning.
Thank you.
What'd you say?
I said that for you.
Yeah. So like we have practice, and as long as it doesn't thunder and lightning, we'll play outside in this. But we're supposed to go to Ohio tomorrow, and it's supposed to rain all day, so we might as well get a rain practice in. I want no more units left. So there should be one specific thing that goes for hours. No. So the unit should get this as well. So you should be able to find hours in our day, and so then the units should be-
So you.
Write it down, I'll check it in a second. Sorry, I just can't lose my screen. To find like this side, but I need to find little a. So technically we could find, you could do a couple of diagrams to get all the way to A. You're on the right track here, but you mess up because you should not use a factor or quadratic function.
This way.
That should be simplified enough. Yeah, that's fine. All right, guys, we got 2 more examples to do. You guys ready for the next side? Elias already started. Okay, so tell me, I know only measure of angle M. What's measure of angle L? How are M and L related to each other? Supplementary, they're a linear, we wouldn't say linear pair, but they're supplementary. And they'll add up to 180. Or I'm gonna do 180 minus 35. And so that's 45. And Lila, were you saying something a second ago? They are congruent because they're opposite angles. So J and L are congruent. So I'm gonna write 45 and 45. That's it. I think that's it. We did it. Yay. We're gonna do one more. We're gonna do this parallelogram right here. Okay, we're gonna break it apart. First, we're gonna find measure of RST. Okay, where's RST? We know a little part of R is 30. What is all of R gonna be? 55. How does angle R relate to RST? T also equals 55. Okay. What about angle S in between them? Supplementary with 55. So I've got a shape that looks something like this, except a better parallelogram. I wish it made my parallelograms like actually parallelograms, but that's fine. S will not be 70. 125. There we go. This is 55. This is 55. And then minus from 180, I get 125. So RST is just 125. Remember when we name angles and we use the 3 letters, I care about going from R to S to T, but it's the angle that's like actually happening at S that matters to me. Yes. That's the, yes. The middle point is your vertex of the angle. All right, what about UTR? What's UTR gonna be? UTR. That's the whole angle. I just want the little part that's UTR.
27.
It's not bisected. It-
I'm confused.
Wait, it would be 32.
Would not be 32.
Oh, 50.
Oh, I'm looking at
50.
30.
Would not be 30.
Is it 50?
No, it's 25.
Oh, it's like opposite. No.
Yeah, finish that thought. Alternate interior
Interior
angles
are.
congruent.
Oh.
So what I've got is I care about this angle right here at UTR, and I can think about, I know UT and RS are parallel because it's a parallelogram, and I can think of RT as being that transversal. They're parallel lines, so I've got alternate interior angles, so UTR is 25 degrees. What about TUR? TUR is, I heard it, 125. Why is it 125? It's the same thing as RST. We already found that one. Oh, and then the last one we're going to find is going to take a little bit of math. This is now a side. Thank you, Maria. Thank you. Do you need this back? You can have that. Or you can throw it away. It doesn't matter. What'd you say? Set what equal? Bye, Maria. Perfect. Why are those equal to each other? They are opposite sides, and opposite sides are congruent. Opposite sides are congruent. So add 1 to both sides, so I get 4b equals 24. And I'm going to divide by 4, and b equals 6. Because that's what the side said. Okay, that's all we're going to do for today. Hold tight for 1 second because I want to show you what your homework looks like. Like last time, I think I put more homework practice than I needed to in here, but I still want you to look at all of these sides for your homework. Okay, I don't have it downloaded on here. There are 3 sides that have 6-1 and 6-2 for your homework, and I want you to do them, except there's a little proof in here that I don't want you to worry about. So the first side says 6-1, do that one. The second side says 6-2, do that one. And the third side says 6-1 and 6-2. I want you to do all of those sides for Tuesday, okay? I know that's kind of a lot, but you guys are going to speed through it because you guys are rock stars. I want you to attempt all of this. If you're not sure, come prepared to ask questions because I'll spend as much time as we need to go over this. We're going to finish our 6-2 notes next class, and we'll get into 6-3 after that. Whew, okay, anybody have any questions? Okay, I'm going to stop this video.